Hello, welcome to General Relativity, Part 1. Let's start by getting a feel of how gravity is different to the electric force that we explained. Here we have Bob and Alice, and we are in an imaginary scenario where fields do not affect the world lines. This is true up to this point over here on Bob, where we turn on the effects of fields on world lines. So here we have the property of mass of Alice, and it creates a field along these information tracks, meaning that we have a gravitational field at this point over here. Now, mass has two roles when a gravitational field hits an elementary particle. On the one hand, the mass value tells us how much the world line's trajectory wants to stay straight. So at this point over here, the mass has a desire to keep the trajectory straight. That is one desire that the mass has. On the other hand, the mass value tells us how much the world line's trajectory wants to change to the opposite information track trajectory. And this is in combination with the strength of the field. So again, if we look at the mass over here at this point on Bob, it has a desire to change Bob's trajectory in this manner over here to this information track. The strength of this desire is according to the mass value and the gravitational field created at this point by the mass of Alice at this point. So this is the second desire of this mass over here at this point on Bob. And the question is, what is the role of mass? What is the desire of the mass at this point? And as we said a moment ago, it seems like it has two desires. One to keep going straight and one to change in this manner along this information track. And as a reminder, this is not the case with the electric charge, where the electric charge has just one desire, which is to move along this information track. And the other desire is the desire of mass. So each charge has just one desire. This question leads us to think that maybe we need to treat gravity in a different way than the electric force. The solution that was proposed is that the mass charge does not create a standard field. Instead, it changes the geometry of reality, meaning mass as a charge redefines what a straight line is. And this allows mass to be identified with just one desire. Mass is the measure of the desire to stay in a straight line of the appropriate geometry. That is the one desire that mass has, to stay in a straight line. Now, what does it mean that the geometry of reality changes? And a way to imagine this is by looking at non-flat, smooth geometries that sit inside our three-dimensional space. So we will use models that are smooth, two-dimensional surfaces. If we zoom in to a small enough area of such surfaces, then the small patch will be close to flat. For example, if we look at this sphere, meaning only the two-dimensional surface of the ball, if we zoom in, then once we get close enough, the surface looks like a flat surface. And if we zoom in enough, we can get to any closeness that we want to being like a flat plane. This is true for any smooth two-dimensional surface. For example, this donut. If we zoom in close enough, a small area of this two-dimensional surface will be close to a two-dimensional flat surface. And we can look at the entire surface as the stitching up of all these flat patches according to the object's geometry at each patch. For example, if we look at this horse and we just look at the two-dimensional surface of its skin, then again, if we zoom in close enough, every small patch will be close to a flat surface. And we can construct the two-dimensional skin of this horse by stitching all these patches together. The two-dimensional surface of the horse can be constructed by taking these small patches. Each one of them is close to the original patch, but each patch is a flat two-dimensional plane. And by stitching all these flat two-dimensional planes together in the correct way, we can get our horse two-dimensional surface. The way to do this is to give each one of these triangles the correct instructions of how to stitch to the other triangles around it. So we can assign each triangle a few numbers that are called curvature, and these numbers tell this triangle how it should sit in relation to the other triangles around it. Now each triangle has this information, and accordingly each triangle knows how it should sit in forming this two-dimensional horse surface. The analog to this process in reality is that the geometry of a small patch is flat, or in other words, it behaves according to special relativity. And reality is the stitching up of all these special relativity flat structures according to reality's geometry at each patch. So each patch of flat special relativity structure has the information of the curvature of reality around it and knows how to stitch to the patch next to it. Now, when we look at these different geometries from our outside perspective, then straight lines look curved, and they are called geodesics. So even though they are curved, they serve the same purpose as straight lines in a flat geometry. Accordingly, geodesics are the shortest path in the direction that we are advancing at. Here we have a two-dimensional surface that is curved, meaning it has a different geometry than a flat geometry. And we have three geodesics pointed out in this two-dimensional surface. So this line over here is a geodesic, meaning it is the straight line of this geometry. And this blue line is also a geodesic. And this other red line over here is also a geodesic. We can already notice something that is different from what we are used to. Between 2 points, we can have a few straight lines, a few geodesic lines that connect 2 points. In flat geometry, between 2 points, we only have one straight line. And the geodesic is if we start going in this direction over here, is always locally moving to the next closest point in this geometry that is in front of it. So depending on how we move, the geodesic is in the direction we are looking at. And this is why when we start looking in this direction, we get this geodesic. And when we look at this direction over here, we get this geodesic. We will talk more about geodesics in the next video and how they differ from straight lines, meaning we will point out the features that we are not used to intuitively. When we think about straight lines, we have a certain way of thinking, and geodesics act in a different way from our intuitive straight line thinking. Going back to the role of mass, the mass affects the geometry, the curvature of reality. We start from a flat structure, and it changes according to the mass charges that are present in it. Now the mass affects the curvature by spreading along the information tracks. So just like the electric field, the mass creates a gravity field through the information tracks. However, information tracks are straight lines, so they are also affected by the curved geometry created by mass. So a mass effect on the geometry spreads through the straight lines of information tracks, and this defines what a straight line is. There is a feedback loop here. Now it's very hard to imagine this subject, but we will jump in and just try to get a feel for it. The solution is a geometry in which the straight lines are how the geometry is determined, and the geometry is determined by spreading along the straight information lines of that geometry. A strange consequence of this is that we can say that sum of gravity is created by gravity itself. Okay, let's try to get the feel for this by using this depiction over here. And here we have a world line, the blue line over here, the blue geodesic is a world line. And we imagine that at this point, these two straight lines over here are our information tracks, meaning the mass charge at this point over here creates a gravity field along these information tracks. For example, if we look at this point over here, it holds certain numbers that tell us what the curvature of reality at this point is. And according to these numbers, our two-dimensional flat model will deform into our two-dimensional surface of reality that includes gravity. However, in this new two-dimensional curved reality, this line is no longer a straight line. So let's imagine that in this two-dimensional surface of reality that is determined according to the numbers of these points in the straight line of our flat surface, this will be a straight line. So this would be the information track. But then if this is the information track, then the information at this point over here that created this two-dimensional surface of reality is not really here. It is somewhere along this line. So the thing that tells us the curvature of reality is along a straight line, and this straight line is no longer a straight line in the curvature that it determines. The actual solution is a solution where at this point we have the numbers that create this geometry over here, in which this information track is a straight line. So the information track has to be a straight line in the geometry that is created according to the numbers the information track points hold. Okay, this is a little bit hard to imagine how it really works, but we can get a field that is a little bit different than creating an electric field. In this case, the field is created according to the numbers that are along a straight line in the created field. This feedback also means that if we have one solution with this world line over here, and we have another world line just like it over here, so we have another solution according to this world line over here, then the solution for both of these world lines together is not just adding this solution with the other solution. Again, this is because each solution is created according to the numbers that are straight lines in its solution. But these are no longer straight lines in the combined solution. And if you heard that general relativity is not linear, this is what it means. We cannot add solutions one to the other. We have to compute the solution as a whole. Nonetheless, reality is the solution. It is the solution of all the world lines together in such a way that if we look at a point, all the gravity field numbers at that point determine the curvature of that point. And in this curvature that was determined, the numbers are the correct numbers according to the information tracks that go through that point. And again, the information tracks are geodesics in the solution. Okay, if we summarize, the idea is that the mass charge affects reality and determines its geometry, its curvature. And in this geometry, in this curvature, the desire of mass is just one, to keep going along a geodesic, which is the straight line of curved surfaces, or in general curved geometries. In the next video, we will look at some of the consequences of moving from straight lines to geodesics, or in other words, some of the consequences of a reality with gravity.